Today we're going to do an example to illustrate how we can apply the fundamental theorem of calculus. So the example we're going to work today is this one. So if f of x is this integral from t cubed dt, we want to find f prime of x. So what does the fundamental theorem of calculus tells us? So the fundamental theorem of calculus tells us that if f of x is continuous over an interval ab and big F is given by the integral from a to x of ft dt, then f prime of x is f of x over the interval ab. If you look at this, at the theorem, you can see that our given integral is a little different. So we kind of have to work it out a little bit to get it in this form from the theorem, and then we can apply it no problem. So to do that, we have f of x equal to integral from x to 2x t cubed dt. Okay, what's the difference between our integral and the TFC, the fundamental theorem of calculus integral? Well, in there, they have an integral from a to x, so from a constant to x. And here we have from x to 2x, and none of those are constants. So we need to do some playing around with our integral. So we're going to separate the two in two integrals. So one integral is going to go from x to 0 from t cubed dt. The other one is going to go from 0 to 2x t cubed dt. And and also we're going to change the sign of the integral, and we're going to switch 0 on x, as we have seen that we can do. So now we have two integrals, and if you look at the theorem, they look very much alike the one we have in the theorem. So that's great, because now we can apply this, the fundamental theorem of calculus, to our situation. So we're going to have what? If we differentiate the integral, the first part is from 0 to x t cubed dt. So we can apply the fundamental theorem of calculus here. So this is minus x cubed. See? Really fast. And now for the other one, we're going to apply 2x t cubed dt. In this case, we have something going from 0 to 2x. We saw from 0 to x. So we're going to change. We're going to call u of x equal to 2x. And we're going to change this 2x to u of x. So we can apply our theorem as we wish. So this is u of x cubed du dx. And if u of x is 2x, du dx is equal to 2. So what we have is 2 times u of x is 2x cubed. And this gives us 16x cubed. So as we see, we switched 2x for u of x. When we do that, we get u of x cubed. And we cannot forget our du dx. In this case, du dx is just 2. And that finishes our thing. Now we need to go back to our first question. And we needed to find f prime of x. So f prime of x is going to be d dx of our whole integral. We have two integrals here, 2x, t cubed dt. But we know we can separate this. So this is equal to 0 to x, t cubed dt, plus d dx, integral 0 to 2x, t cubed dt. We have done the calculations. So we know that this is minus x cubed, and the other one is plus 16x cubed. So our answer is 15x cubed. And that's our final answer. F prime of x is equal to 15x cubed. That's the answer we got doing this. I hope that helped you. And that's it for today. Thank you.